Okay. Hi, everybody. I'm Sebastien Deleuze. I'm a Spring Framework committer. I work at Pivotal, and I'm also an organizer of the Mixed Conference, which takes place in France, in Lyon, in April. And today we are going to talk about why Spring loves Kotlin and how you can build Spring application using this language. Current most popular way to build web application is using Spring Boot 1 and Java. And today we are going to see how far we can go using Spring Boot 2, which has been released quite recently, and Kotlin. Last year, I announced the Kotlin official support in Spring 5, and we got a lot of good feedbacks, a lot of people interested, and we have continued since to work on that support, to polish it, and I'm going to present it to you today. What we're going to see today is based on a real project, which is Spring Kotlin Deep Dive. You can see the source code on GitHub. It's a blog post built with Spring Boot 2 and Kotlin. So feel free to have a look to the source code if you want to get a deeper understanding on what occurs. You will see that there is various branches, step 1, step 2, step 3, step 4. And you can see the various steps of the migration from Spring Boot and Java to Spring Boot 2 and Kotlin. So for the first step, we are going to switch from Java to Kotlin without using any Spring Kotlin support specifically, but just changing the language. In the second step, we are going to migrate from Spring Boot 1 to Spring Boot 2, which is based on Spring Framework 5, which support natively Kotlin. Then we are going to switch from Spring MVC to Spring WebFlux. So that's perfectly fine to use Spring MVC for your project if you don't need a non-blocking reactive runtime. But we will see that Spring WebFlux open new capabilities, and we are going to explore that. And at the end, we are going to switch from the regular annotation-based programming model that you are likely to already know to the new functional API and the Kotlin DSL. So step 1, from Java to Kotlin. The easiest way to start a new Spring Boot project with Kotlin is to go to start.spring.io. You can see that there is a special URL that will automatically select Kotlin language by default, or you can select it in the combo box. In this slide, at the left you have at the left you have the Kotlin code, and at the right you have the Java code. You can see that Kotlin code is much shorter. So that's not much about writing code, because you all have IDEs that allow to write code quite fast with automatic generation of getters, setters. But when the time comes to read this code and to debug it, I think the signal on noise ratio of the Kotlin code is much better. So in this Kotlin code, you can see that we are using data classes. So the data keyword means that you automatically generate toString equals hashcode. You can see a short notation to declare at the same time the constructor and the properties, similar to what you have in Scala. Val means that's immutable. So usually Kotlin favor an immutable-based usage, much more than Java. So val is for immutable and var is for mutable. You still use the same annotations. So in that case, that's Spring Data MongoDB annotations. You can provide some default values for your optional parameters. So usually I put this kind of parameter at the end. That means that you can create an article without specifying the date, and it will automatically set the date to no if you don't specify it. That's avoid to have overloaded version of the constructor. And so much shorter code, easier to maintain. So that's just for fun, but you can use emoji in your test names, and globally you can use real sentences that provide a more meaningful test name that the usually camel case notation. So when you use backticks, I usually use that for my test, not that much for my production code, but for tests. I think that's quite useful. That's a regular Spring MVC controller written in Java, so nothing surprising. It is annotated with @controller. It will usually be used to produce JSON, for example, or XML. You can see that we are using the implicit auto-wired as of Spring Framework 4.3. If you have a single constructor, it will be parameters of this constructor will be automatically auto-wired. So that's like if the constructor was annotated with auto-wired, so user repository is injected. And get mapping, post mapping, etc. are aliases to request mapping annotation, and they specify the HTTP method. So here is the Kotlin version. So you can see that it's shorter. We use the same constructor-based property declaration. By default, the property are public, so here we use private because we don't want to expose directly the user repository. You can see that Kotlin provide a short notation for one-liner functions that leverage type inference. So in fact, this code is as statically typed as this Java code. This is not like dynamic languages. Find one as a return type, but it will automatically take the return type of a repo.findOne, and that will be inferred by the compiler. You can, if you want, if you prefer, specify the return type explicitly. That's possible, but it's up to you. And usually in my code, I avoid to repeat an information that the compiler can automatically infer. That said, it could be useful to see the return type for debugging purpose or code review. So in ID, you have a setting that is not enabled by default, but you can show a function, property, and local value return type ints. That way, IntelliJ ID will automatically show you the inferred type, a little bit like you have a parameter names type int in ID. So feel free to enable that. I enable that in all my projects because that's allowed to clearly view what are the return types. When we started to build Spring project with Kotlin, there was some glitches. One of the glitch was that Kotlin by default, in Kotlin by default, classes are final. So we had to use the open keywords to make them open, and open classes and methods are usually needed for add configuration classes, for example, or transactional classes, because Spring with CGlib extend it at runtime, and if the class is final, that don't work. So we discussed with the Kotlin team, and they ended up to provide a Kotlin Spring plugin, which will automatically open every Spring annotated classes. So as with this plugin enabled at Maven or Gradle level, as soon as you have add configuration, add controller, add async, the related classes or method will be automatically open, and that allow you to don't care about that and just use the default behavior and avoid to have this more verbose Kotlin version. So something important that this plugin is automatically configured when you generate your project on start.spring.io, so you don't have really to care about that. It isn't automatically provided. Now, Boot 2. So Spring Boot 2 has been released a few days ago after a long milestone and release candidate phase. So it's quite polished, and kudos to the Spring Boot team, which has done a huge work to provide various features like integrating all the new WebFlux infrastructure, providing Kotlin support, and various other things. notice that there has been a lot of work also on start.spring.io site for Kotlin support to provide, for example, the Jackson Kotlin module automatically. So every kind of things that make your Kotlin experience smooth from the start. And yeah, that was a long journey, but currently we have, with Spring Boot 2, we have official Kotlin support end-to-end in various parts of the Spring framework, of the Spring projects. So when I say that Spring loves Kotlin and officially support it, that means that there is Kotlin support deep into Spring Framework 5.0 that has been released a few months ago, but also in other projects of the Spring portfolio like Reactor Core 3.1, Spring Data K, and Spring Boot 2.0, and support is coming in other parts of the Spring portfolio. Kotlin support is provided out of the box. That means we don't provide some kind of spring-kotlin.jar module. The Kotlin bytecode is directly provided into Spring Framework, Spring Data, and Spring Boot jars. When you are using Java projects, they are just not used, but as soon as you use Kotlin, they are used, and that's a very thin layer of functionality on top of the Java ones, because one of the Kotlin's key points is that it has a very good Java interoperability. So Kotlin API is basically Java 1 plus various Kotlin extensions and other things. There is an official documentation, so reference and API documentation in both Spring Framework and Spring Boot. So feel free to have a look. This is quite detailed, and it will provide you every kind of information you need. So with Spring Boot 1, when you want to run an application with Kotlin, you had to use this kind of syntax. So application semicolon semicolon class.java is to be able to get the Java class from the Kotlin one. So that was not super idiomatic. So in Spring Boot 2, we provide a run application, a top-level function that allows you to specify directly the application to run. The class should be full application. I need to fix that slide. And it also provides you the possibility to declare additional bins, like in Java. Here we also take advantage of the type difference. And the run application provides you also the possibility to customize the generated application with this kind of syntax. Another feature that we provide is to leverage Reified type parameters. So in Java, there is the type erasure issue that makes generic types lost at runtime. And sometimes, for example, when we want to get a list with a REST template, it's forced to use a not so nice syntax to be able to specify that that's a list of articles. So you have to use this quite ugly new parameterized types reference with the generic types. And with Kotlin, we are able to provide the same kind of functionality, but with a very nicer syntax. And that's done by providing an extensions. That means that with Kotlin extensions, we can add Kotlin-specific functions, member functions, to existing types. So in this example, we provide an exchange extension to REST operations, which is the interface behind REST template. And we provide basically an alias to provide a better syntax. And Kotlin provide extensions for the whole Java JDK, so on string, on various classes. So that's a very useful mechanism that we provide to enrich current Spring API with Kotlin-specific features. Another very useful feature of Kotlin is null safety. So in Java, nothing is enforced at type system. So null safety is a kind of dynamic aspect of Java, since we don't specify it in our API. There is no check at compile time, but there is null pointer exception at runtime when we forget to do some tests. And we can use optional, but optional is not usable everywhere, mainly usable for return values. It has performance impact if you use for the internal implementation of your classes. It's not a good fit with parameters, so optional is not an universal answer. And so in Kotlin, there is various type of developers. Some developers are really heavily functional and prefer to use optional like type, but the majority of developers in Kotlin are using the fact that null safety is explicit in Kotlin. So by default, a type is not nullable, and you have to add a question mark at the end to specify that's nullable, and that provides full check at compile time, no null pointer exception, and functional constructs are provided on nullable values. That's allowed to use nullable values to signify that a value could provide a value or not. So it's not a bad thing in Kotlin to use nullable values. It could be used as a clever way to signify that something will or not return a value. But Spring Framework and Spring Boot and Spring Data are in Java. And so when you use the Java API with Kotlin, basically Kotlin has no information about the types, the null safety of the Java API. And Kotlin interprets Java types as platform types. So the nullability is unknown. That's with this exclamation mark. And and basically with that you can still have null pointer exceptions. So when you are using your libraries, and you are using libraries in various parts of your code. So what we have done, we have worked with JetBrains quite a lot to provide null safety annotation. So we have annotated the whole Spring Framework and Spring Data code base to provide null safety annotation of all our APIs. By default, we set the default to non-null at package level. And we specify nullable return values or parameters with @nullable annotations. And with this -x GSR 305 equals strict compiler flag, which is enabled by default on start.spring.io, Kotlin will automatically leverage this information to infer the nullability of Kotlin API, of Spring API. That means that when you are using our REST operation method, Kotlin know for sure if something could return null or not. And concretely, that means that where you are using Spring API with Kotlin with this flag, you have no risk anymore to have null pointer exception, because that will be catched before with the compiler. If you don't do the related check, it will be in red, and you will have to write some code to deal with that. So that's I think that's one of the major features. Spring Boot 2 does not use that for its own API, but I think it will be the case in 2.1. We still have to work on that, but for the whole Spring Framework and Spring Data, they are annotated and they provide you a null-safe API. We also leverage Kotlin nullable information to determine request param and auto-wired required attributes. So that's an attribute that you have to set in Java explicitly to make a request param optional, for example. And with Spring Boot 2 and Spring Framework 5, we will automatically leverage the null safety, the nullability of a parameter to know if the required parameter of the annotation should be set to false or true. So if in this base annotated request param, it's nullable, that means that required is automatically set to false. And it's also usable for injection. So when you have foo, non-nullable foo, that means that a bin of type foo needs to be present in your application context. And if the bin is nullable, it's optional. That means that if the bin of type bar is not present in the application context, a null will be injected and there will be no error at startup. So that's leveraging the Kotlin type system to provide automatically information to Spring existing notions. Some words about testing. So you can totally use JUnit 4 for testing your Kotlin code, and there is various Kotlin testing libraries, but I usually prefer to use JUnit 5, which is supported by Spring Boot 2, not enabled by default, so take care about excluding JUnit 4 and importing JUnit 5. You will have more information in the reference documentation, but what is interesting with JUnit 5 is that it supports non-static before all, after all. That's same that before class, after class from JUnit 4. And JUnit 4 only supports static method for that, and that's not a very good fit with Kotlin, because Kotlin don't have directly static method support. They have companion object, which is kind of the same thing, but the syntax is more verbose, and that's not super idiomatic. So by using JUnit 5 and enabling the per class lifecycle that allow to instantiate a class just one time and then run multiple tests, then you can use a non-static before all and after all annotated method, and that's a pretty good fit with Kotlin. That's a similar feature that TestNG has for years. So yeah, feel free to use that and to configure the per class lifecycle with JUnit 5 and Kotlin. Also, an interesting feature of JUnit 5 is that it supports constructor-based injection. And that's a good fit because with Kotlin, since Kotlin deals with null safety natively, when you have separate instantiation of your class and initialization of your properties, basically you have to use nullable variables or late init variables in your tests in your classes, and that's not super idiomatic. If you are directly using constructor-based annotation injection, and I usually advise to use constructor-based injection, you can directly use immutable values, and that's perfect. So you can use constructor-based injection with JUnit 5. So feel free to use it. That's a good fit with Kotlin. Now we are going to talk about WebFlux. So Spring Framework 5 introduced a new web stack, which is Spring WebFlux, which is non-blocking and based on reactive streams, in addition to Spring MVC, which is blocking and based on servlets. So blocking is not a bad thing. Spring MVC is still supported, not deprecated at all, and still usable for a lot of use cases. But when you need to go the extra mile in terms of scalability, in terms of streaming, when you request a lot of remote services with latency, that's something that scales better because you don't have one request equal one thread, and so you are able to deal more efficiently with streaming use cases and scale better when you have a lot of concurrent requests. So you have basically two parallel stacks. The servlet one, which is based on the ad controller programming model, based on servlet containers like Tomcat and GT. And you have the new reactive stack, Spring WebFlux, which allow to use new runtimes like Netty and Undertow without using any servlet API, which is based, it still reuse the ad controller programming model, but also provide a functional endpoint programming model that we are going to see at the end, and provide a reactive client. So WebFlux support various non-blocking APIs, the ones provided with Java, like Completable Future and Faux Publisher, Eric Java, Reactor, and you can use any library that supports reactive streams, like Akka and others. Internally, we are using reactive streams and Reactor, but you can really use the one that you want. In this example, I'm going to use Reactor for that purpose. So Reactor provides two main reactive types. Mono, which is a reactive type for 0 to 1 elements. That's a kind of reactive promise, reactive future. That's a little bit like completable future. And Flux is for reactive collection and streams. That's similar to flowable or observable for Eric Java. And both are based on reactive streams and provide a wide range of operators that allow you to transform the data. So using Spring WebFlux with annotation is quite similar to, in terms of annotation and programming model, to Spring MVC. you still use @RESTController, @GetMapping, but you see that the types used are non-blocking types, so completable future, mono, flux, observable, flowable, etc. And so that's interesting to notice that that's usable only if you the API that you are using use these non-blocking types. That means that you are likely to use Spring Data K reactive support for MongoDB, Redis, Cassandra, Couchbase. You can also use the reactive client, web client, which provide Flux and Mono. You can use any kind of library that return non-blocking types. If you are using blocking types, that will work, but with bad scalability, so that's not something we advise to do. Notice that if the programming model is similar, the implementation will be quite different because reactive APIs mean using functional programming. So instead of writing imperative code with different lines like you do usually, you will write functional code like that by chaining all the steps. So that's quite different implementation. So even if the annotation look like the same, the implementation will be quite different. We provide Kotlin extensions for Reactor. For example, it allows us to add 2 mono methods to every kind of object. Notice that extensions need to be imported. That's a little bit like static import. So it's not something that comes magically into your code. They have to be present in the class path, and then you have to import explicitly like static imports to use them. Usually the IDE does a pretty good job to provide you some hints to import them easily. Notice also that, for example, the last example with we have an extensions which is called Reactor Mathematic Extensions, and since Flux is some type that we can't extend in Java, we have to provide matflux.average double. And the nice thing with Kotlin extension is that we can directly add an average operator to the Flux type, and it will be only available on Flux of numbers. So you can also restrict extensions to make them usable only on a specific generic types. And now we are going to see Kotlin DSL and functional APIs. So this is WebFlux functional API with Kotlin DSL. So WebFlux provide, in addition to the annotation-based programming model, it provides a functional API that is similar to what you have in other technology and other frameworks. So that's a Lambda-based programming model, which allow you to write your routes, not without annotation, at request mapping annotation like usually, but using a kind of DSL. So that's available in Java, but that's quite verbose. But with Kotlin, that provide us a way to write a nice syntax like that. So you can see that I specify the media type, text HTML. Then with the nest operator, I provide nested routes. So slash will render index. So you can see that it supports template rendering. That's not only about JSON, XML support, etc., but that's also about template rendering. We support also server-sent events and regular JSON and XML. So that's just another way to write your code. In this example, I have mixed. That's a very simple example where I have mixed in the same place the routes and the handlers implementation. But in real life, in concrete project, you will usually separate both routes and handlers. So in this example, which is integrated in Spring Boot application, you see that I'm using the router DSL to declare various endpoints for JSON, for notification with server-sent events and with HTML. And we use method references to just point to the handler that will be called. Okay. So the nice thing with this syntax is that I think it's quite readable, and it gives you the power to choose the granularity of your routes. With annotations, you have all your routes spread into all your controller classes, so it's not always easy to have a global view of that, and that's where Spring Boot actuators help. Here you can decide to put all your routes in the single monolithic router, or you can also provide mini routers provided in various jars. You choose how you group your mappings. On the handlers side, you see that you will inject services or repository, and then handlers are just functions, okay, that take a server request as input and return a mono of server response, so a kind of a future of promise of server response. We provide an API to make it easy to render specific templates, render JSON, call server-sent events, and you will use repositories and services that you have injected into your handlers, and that's regular components. So what are the remaining pain points we would like to fix? I think we have currently a really good level of Kotlin support, so there is no big blockers. We have been polished that for years now. We had a lot of feedbacks, and I really think that's usable in production for your project with Spring Boot 2. But there are a few pain points, and the first one is immutable configuration properties. With Spring Boot 2.0, you have to use late init var to use configuration properties, because configuration properties does not support classes with immutable values for now. That could be the case maybe for Spring Boot 2.1. We are going to work on that, but currently it is not supported, so you will have to use this late init var notation to make it possible for Spring Boot to instantiate foo properties, and then in a second time to populate the properties. But that will be much cleaner to have immutable values, because usually your properties won't change at runtime, and also to support data classes with the short notation. So we are going to work on that for the next version. I think with the late init var trick, it's quite usable, and we have big project using that, and that's perfectly fine. So that's just something to have to know. A more annoying issue is web test client. So web client is the new reactive API that we provide in Spring Framework 5, and it's usable in, that's basically a replacement for REST template with a Fluent API, and that's usable even in your Spring MVC project. So when you use Spring Boot 2, please, you do what you want, but I advise you to use web client and not REST template. It's much more powerful and usable in all the cases. But the testing version, which provides some kind of mock MVC functionalities, which is web test clients, is sometimes unusable with Kotlin due to a type inference issue. So you have the reference of the Kotlin issue. Kotlin team is aware of that, and they may fix that in Kotlin 1.3 with a flag, but it should be fixed in 1.3 with a flag and 1.4 without a flag. So yeah, finger crossed to make that fixed. For now, just use web client in Kotlin, or if you are blocked, use web test client in, write your test in Java for that. But in my project, I prefer to use web client in Kotlin. Another interesting point is coroutines. So I consider coroutines as an additional way to provide, to expose non-blocking features from WebFlux. So we can see as an additional support. There is a community project done by Konrad Kawinski, which has done a very good job. So that's not supported natively by Spring for now, but there is a very good quality project which support it. So coroutines are Kotlin lightweight threads. They allow non-blocking imperative code. They are less powerful than Reactive API in terms of backpressure streaming operators, but they provide a nice syntax, especially for single asynchronous values. So if you want to use that with Spring Boot 2, use the Spring Kotlin Coroutine project. Be aware that coroutines are still experimental, and we are currently working on that and experimenting about that. Concretely, in terms of interoperability, when you have a single asynchronous value, which is mono or completable future or something, when you are using coroutines, you will call a suspendable function that will return t or nullable of t. So you see that for single values that allow to remove the wrapper and write code that are like if it was imperative code, so that could be seen as an advantage for simple use case. For asynchronous collection, mono of list of something translate to suspendable function that return list of something. For streaming, you have to provide a special type. So here, there is no magic. Instead of flux of t, you will use receive channel of t. And for async completion, you will just return use a suspendable function that return nothing. So there is a step 3-coroutine branch in my Spring Kotlin deep dive project that show an example of the project with coroutines. So you will see that the code is quite close of the Spring MVC version and not of the Spring WebFlux version, because that basically allow you to write to leverage the non-blocking runtime, but with a more imperative style syntax. So that works quite well for asynchronous values. When you are doing a lot of streaming and things like that, I think the advantage is less clear. But yeah, that's something worth to try. Boot plus functional bin DSL. So Spring Framework 5 introduced functional bin definition. It's a very efficient way to declare your bins with no reflection, no CGLib proxies. It's using lambdas instead of annotations. And it's both declarative and programmatic. So functional bin definition with the Kotlin DSL is like that. So in Spring Framework 5, we have two DSLs. We try to not provide too much DSL. We have the router one that we have seen before, and here is the bins one. And it allows you to declare bins with this kind of syntax, which is Kotlin code. So that's a kind of a trade-off between Java config and XML or YAML or thing like that. You can provide any kind of customized condition because that's code, so you can use something that we provide by default. For example, we provide an environment helper, but you can use every kind of custom conditions to register your bins. And yeah, that's pretty interesting. You can also use both DSL together. So bins plus router DSL fit well together. So in that one, I'm using the bins DSL, and inside the bins DSL, I'm using the router DSL to declare various routes. So you can see that's another way to build your application context, and yeah, that's something that could be interesting. Currently, it's possible to use it into Spring Boot, but there is no first-class support, so you have to plug it manually. You can go to this issue that will explain you the detail, but maybe later we will work on some more proper integration to allow you to declare your bins with this kind of DSL. You see that in Kotlin, DSLs are more idiomatic than annotations, so we try to expose our programming model with Kotlin DSL to provide more flexibility, more power. And the last part of my presentation is about multi-platform support. So Kotlin has first-class JVM support, and that's what we have talked about today. We provide first-class support for Kotlin. Android also provide first-class support as announced by Google a few months ago. But we have also, Kotlin provides support for JavaScript, so you can write front-end project in Kotlin that transpiled to JavaScript. And there is also Kotlin native, which also to allow to use Kotlin without any VM with the LLVM toolchain. Just be aware of something, you will not write the same project and compile it to JVM, JavaScript or native. You will use the same language, but the libraries that you are using are super different. So it's not about writing something once and run it everywhere. it's using the same language, but take in account that the ecosystem is different. So for example, in Kotlin native, you will not use Jackson to serialize JSON. You will use native C library that has binding to Kotlin native. That's different compared to other technology. So you can use Kotlin for frontend today with Kotlin JS. This is the original JavaScript code from my deep dive project. It's allowed to show notification when there is a new blog post created. So this is the JavaScript version. This is the Kotlin version. So verbosity is the same, but the nice point is that you have all the Kotlin features of type safety, null safety, only 10 kilobytes with dead code animation tool. That's a code that is quite similar to TypeScript, for example. But if you want to write all your project with a single language, that could be interesting. But for the long term, I really believe in WebAssembly support. So WebAssembly is a technology that allows to run a sandbox native platform for the web without any plugin involved. That's pushed by the W3C. You can see this very good introduction to WebAssembly by Lynn Clark from Mozilla if you don't know the technology. And so Kotlin support WebAssembly. It's experimental via Kotlin native because LLVM toolchain can generate WebAssembly code. And that could be a better compilation target than JavaScript because that's a proper bytecode. It's built for performance, for low memory usage. There is currently some showstopper, at least for a real production grade usage. So DOM API and garbage collector are not available yet, but are coming. But for the long term, that could be a nice platform, and a Kotlin native front-end ecosystem could arise. So that's something to have a look for the future. Notice, I think one of the key strengths of Kotlin is that it allows to share code between platforms. So you have multi-platform data types and serialization that are coming. And maybe we will support that in Spring. That's not yet available, so I don't know. But the idea is to be able to write some part of your code that is multi-platform, so the same for JavaScript, JVM, and native. And you will provide some implementation that are platform-specific. So basically, the idea is to provide 80% of shared code, and you will only provide the implementation that are platform-specific. So that's the initial support is provided with Kotlin 1.2. I think it will take some time to mature the libraries and things like that, but that's an interesting point to follow. That's all for today. You can have a look to the slide on speaker deck. You can follow me on Deleuze for fresh Spring and Kotlin news. I have built this last year various applications based on Spring and Kotlin, so feel free to have a look to the Mixit conference website, which is a real non-demo project based on the stuff that I have showed today. Spring Kotlin Full Stack, which is a project with Kotlin used for both front-end and back-end. Spring Kotlin Deep Dive, which is a project behind this presentation, and Spring Kotlin Functional, which is a pure Spring Framework 5 functional API, beans and router, without directly usable in standalone mode without Spring Boot. Thanks for your attention, and if you have some question, we can discuss after the talk. Thanks.